Tangent and normal. Find tangent equation to curve y equals open bracket 4 minus x close bracket times open bracket x plus 2 close bracket at the point x1 and y1. To find the equation, if you know the gradient and you want to find the equation of that line at a point, it's always best to use y minus y1 equals m of the tangent times x minus x1. You can see this is your x1 and that's a y1. So now we need the gradient, the tangent gradient mt. We know that mt is the y, the x for the tangent. And we know the equation because we have the equation, so we can find the gradient. But with this equation, I can use product rule to find the gradient because that's a product, one function times another function. Or I can just expand this function and then differentiate term by term. So if I expand that, that will be 4 times x, so that's 4x. 4 times 2, that will be plus 8. Minus x times x is minus x squared. Minus x times 2 is minus 2x. And therefore, we get y equals, I've got 8. Now, 4x minus 2x is plus 2x minus x squared. So this is the function. Now, if I differentiate this function, I get the y, the x, gradient of the tangent in this case, will be, if I differentiate a constant, just do remember that a constant has, in this case, 8, x to the power 0 equals 8. But whenever we're differentiating, we want to have y in the form of x to the power of n. That's what we want. So this one doesn't have x, so we can put it in x to the power 0, because that's x to the power 0 is 1. So that would be 8 times 1, which is 8. And then the gradient for that, the y dx, is n x n to the power minus 1. And so that's what we're doing here. For n is 0, so 0 times 8 will be 0. So that will be 0. A constant, if you differentiate a constant, it's 0. Plus, well, for 2x, 1, and n is 1, so 1 times 2, so we could put 2 there, and then we get x to the power 1 minus 1 minus, well, this is 2, there's a 1 here, so 2 times 1, so that's 2 there, and then x to the power 2 minus 1, and we then get 2x to the power 0 minus 2x to the power of 1. So the gradient here is actually 2 minus 2x. So that's the y dx. Now we need to find the y dx when x equals to 2. That's what we want because x equals 2 there. So we want to find the y dx when x equals 2. And that would be 2 minus, because of that 2, because of the value of x, 2 minus 2 into bracket 2, and that will be 2 minus 4, and therefore the gradient is minus 2. So mt is minus 2. Now we can plug minus 2 into there, and then we can plug x1 into there, and y1 into there. And that's how we find the equation of the tangent. So y minus 8, because y1 is 8, equals mt is minus 2 times x minus 2. That's minus 2 there. So that's 2. So we need to expand that. So that will be minus 2x. Minus 2 times x is minus 2x. Minus 2 times minus 2 is plus 4. Y minus 8. Therefore, y equals minus 2x plus 4 plus 8. Adding 8 to both sides or moving minus 8 to the right, the sign will change to plus. So therefore, y equals minus 2x plus 12. So the equation of the tangent is y equals minus 2x plus 12. Also write that equation as y plus 2x minus 12 equal to 0. X is before y, so we can say 2x plus y minus 12 equal to 0. So I've written that in the form of ax plus by plus c equal to 0. So you could be asked to write the question in terms of y equals mx plus c. So that would be y equals mx plus c, or ax plus by plus c equal to 0. So those are the two ways you could be asked to write it. Or you could be asked to write it like that. So you just put your minus 2 there, and then you put y. So you get y minus 8 equals minus 2, open bracket, x minus 2. So you could be asked to write it like that. All three ways is possible. Read the question carefully before you finish your answer.